We're here in Hertfordshire, in the UK, on the former site of a historic cardboard and plastics factory, where a series of fuel storage tanks had leaked over time, impacting the underlying soil and groundwater. The site is now being redeveloped, and although it remains light industrial in use, the petroleum hydrocarbon contamination does require remediation due to the risk posed to the environment. Immediately adjacent to the site is a sensitive and protected chalk stream. Working with the environmental contractor Rake Remediation and WDE Consulting, Regenesis helped devise a remediation strategy that will be completed in 2 phases.
The first phase, which is going on at the moment behind me, is the installation of an in situ permeable reactive barrier, or in situ PRB. This is comprising 2 rows of ORC, our oxygen releasing compound, and then a 3rd row of Petrofix that is being injected perpendicular to groundwater flow up gradient of a chalk stream to prevent the off-site migration of petroleum hydrocarbon contamination impacting that stream.
Once this in situ remediation work has been completed, Rake Remediation will continue with the 2nd phase of the works, starting with the targeted excavation of grossly impacted soils, coupled with physical abstraction using pump and treat.
Once that pump and treat system has reached an endpoint, the residual dissolved phase contamination left in those source areas will be treated utilizing in situ chemical oxidation. The technology that will be used there is a technology called Regenox that will be applied over a series of campaigns.
This site is about 1 metre of made ground over chalk, groundwater coming in at about 1 metre below ground level. We are injecting between 1 and 4 metres below ground level. We have a very high voltage substation behind us. We have exposed underground high voltage cables so that we know exactly where they are, so we're in no danger of hitting them with the rig when injecting.
As part of the remedial design process, when Regenesis has been asked to look at different options for groundwater treatment, the proximity to sensitive receptors will always be taken into account.
One of the things that we don't want to happen is any of the products that we have making their way into the river course. So as part of that design process, we look at the anticipated radius of influence from each of these injection points and then offset those injection points away from the river with a good safety margin to ensure that sensitive receptors are not affected by our works.
The machinery involved consists of a simple mixing plant and injection pump manned by 1 person and a direct push rig manned by a 2nd person. This contrasts a lot with a similar project that I undertook about 20 years ago, where to achieve the same goal we had to install a long sheet pile wall consisting of a funnel and gate system with 3 concrete manhole rings making activated carbon filters. A big piling rig, couple of 30-ton excavators, and an enormous civils cost. There were probably at least 15 people on that site, and there were obviously health and safety implications with that number of people and that amount of heavy machinery working. This one is complete simplicity and contrast. Everything is small, cheap and easy. The ORC was a simple 150 litres per mix. The Petrofix is a lot more. We're managing about 1,200 litres per point. So we manage 5 points of Petrofix a day, which is happy.
Once both phases of the works have been completed, the environmental consultant, WDE, will carry out several rounds of validation monitoring to ensure the remedial targets for soil and groundwater have been achieved, after which the site redevelopment can go ahead as planned.